ahead and done is, based on the conversation I had with everybody last week, I preset the baby on what they said is the most typical setup for what you guys are doing. Okay. So I have the circuits running into the center opening connected to a RAM cannula, and that's probably a common way of how it looks. So does anything here look out of ordinary for you guys?
No.
Okay. So right off the bat, when you look at this, and I'm going to go ahead and show those to you. So first things first, the biggest problem is the circuits running through the center opening. So this is convenient for a lot of people to use. Fisher and Paykel in particular, and respiratory care in general, like the circuits going from here down to these side corner holes. The reason why is what you have heavy air coming in this direction that's humidified. And then it goes to the baby, and then as the air is leaving out the expiratory limb, water is collecting. And what does water do? It likes to run downhill. So instead of leaving the expiratory limb, the water is just cooling up in wherever the U-bends are located at. And whenever you run this through the center opening, you almost invariably know you're creating this apex, so the water just continually flows down this direction and starts to fill up this area with water. If you use a circuit holder as well, that only compounds the issue, because now you have multiple apexes and all kinds of things that are collecting.
So even if you position it all the way down the bottom of that opening? If
you position it down the bottom, this is definitely more ideal. Sometimes the circuits then are laying over this plastic part, you keep another apex. The problem with this one is that means you'd have to get 100% of the RTs and nurses doing that 100% of the time. And it's too much of a variable where we go into hospitals and they just find a way. Over time, the circuit starts to rise. When you put it in a side corner hole, it's a finite thing. There's nothing you can do about it. When you put it there, that's where it goes. So let's visually take a look at that.
And then our tubing would be coming out over the back, but if we can
Come from the side.
Yeah.
It would look something.
Our vent's going to be over here.
Right. So it looks like that. Already right off the bat, when you can take a look at it, the water is already flowing down. Everything is starting to get below the patient interface here, and the water is going to start to leave. Otherwise, you're just fighting against physics. Okay, so that's number one. Number two, the way these inspiratory limbs are designed is the temperature when the air comes out here is 40 degrees, because every 2 inches, the air cools by 1 degree. The problem is that when it's used on a Fisher and Paykel interface, that's already incorporated, so you get 37 degrees to the baby. The other problem is that if the temperature drops below 37, then we hit that dew point threshold. And so every degree that's dropping, more and more rainout is building up. So we have two things that are causing a great deal of rainout. Number one, all of your RT265s come with this extension unit. We've been trained over the years that you had to use an extension unit to keep the temperature probe out of the incubator. You don't have to do that anymore. I'll explain that in a minute. But what you're doing when you're taking out the extension unit is you're taking out 10, 12 inches. So you're taking out 6 degrees of potential droppage and all the water that accumulates into that. So now we've cut that down. So 40 degrees goes here rather than way back here, and then all this stuff is dropping. The tricky part is because you guys use the RAM cannula, the cannulas by their very nature do increase rainout because they have high resistant tubing where air is being pushed into it. And then this is a very long piece rather than a true CPAP idea. But this is what you guys use, so we're going to make this work. So it'll continue to decrease in temperature, and you'll still get some rainout in the cannula, but we're going to fight that a different way. So
the infant's still going to get 37 between the 40.
No,
37,
no.
or?
If you use a cannula, which is not rated for CPAP, that's going to be internal for you guys to make that decision. But they won't be getting 37. There's no way we can make, because this is not designed for CPAP. It's not designed to do this. But you guys are using it for that, and so that's something that you'll have to accept.
Oh, this is not designed for CPAP?
No, these are not approved by FDA for CPAP. They're used for CPAP, but they're not approved for CPAP.
So
Okay.
what temperature might they be getting?
So let's take a look at it. So theoretically, let's say that's about, what, 10 inches long? They'd be getting about 35.
Okay.
They'd be getting about 35. And you will break that dew point moment where water's going to start to build up. But we're going to find another way to get rid of it. So we've taken out the expiratory limb, we run it through the side corner hole. Instead of using a circuit holder, because circuit holders just rise, take a blanket, and we want to support this heavy portion here with a towel. Now what we're trying to do is we're trying to get the expiratory limb below the interface. You always want the expiratory limb below the interface because that's where the water runs out. So if we can get this downward angle with your ram cannula, like so, where it's flowing down towards the expiratory limb, you'll eliminate so much rainout just by simply doing that. Okay. Problem is let's say we have a baby in prone position, which is a very common position for babies in this. Now the water is going to collect right here on this barrel. You have to be mindful of that. It's very challenging to get the expiratory limb below it, but still you want to make sure that as best you can, expiratory limb is below the cannula. Okay. People ask, why are you allowing the temperature probe now in the incubator? I've always been told I need the extension unit because we want the temperature probe outside the incubator. The reason why is back when we used old incubators, we used to set the temperature to 36, 37 degrees manually, and that's what babies would go into, and that used to cause havoc on the temperature probes themselves. And so they created distinct extensions so the temperature probe would stay out. Now that with these brand new giraffes and all the different incubators out there, all the nurses put their babies in the baby mode. If you ever look at an incubator that's in baby mode, it typically stays between 32 and 34 degrees Celsius during the entire time, and that does not cause haywire on these temperature probes. So the temperature probes can go inside the incubator as a result. The other question I had is can we use those kind of strips that go on the outside of the temperature probe as a reflective? That's for infant warmers. They used to create a reflective strip that would go over the temperature probe because the infant warmer would shine radiant heat onto this, and that would cause that to spike the temperature, but that's for infant warmers only. Okay. Final thing is a question from one of the RTs was, what about ambient airflow? So let's say this temperature probe was underneath an air conditioner or a heater, will that cause a haywire? It will, first off, if the temperature probe is outside the incubator and underneath it. So if you insist on using the extension unit, let's create that. If you say I need to use the extension unit because that's just too short for me, whatever your reasoning is. And let's say this is outside like this. Now we've got the temperature probe outside, and whatever, let's say an air conditioner is piling down on that, or a heater, that will cause a problem if your temperature probe, you know, it's like kind of got that like teal color temperature probe, is not seated all the way. If you can see even a little bit of teal sticking out, it's taking an average reading of the air around it. And if it's taking in that air conditioner, that heater, it's going to give a false reading inside that circuitry. So you got to make sure it's seated all the way down and you don't see any other teal. But the fastest and easiest way to eliminate any ambient air that's happening outside is just take this extension unit, which comes in every single kit, get rid of it, and plug this in like so.
So it's always going to be more stable temperature inside the isolate.
Always.
Because it's stable temperature for the
Stable,
baby.
stable.
as opposed to
So
the
you
air.
want that in
So
there.
you always want to take that. That's what you're recommending.
Yeah, because I mean, because you're using a cannula and that's already decreasing the temperature by potentially 5, this is decreasing your temperature by potentially 6, that's 11. Whether it drops down to 11, there's some point where it's not going to go that fast, but still you're just creating a rainout machine when you combine the two together. If you were to use a CPAP interface, they've been designed by all the manufacturers to be a certain length to reduce the temperature only so much from this point. But that's not what you're using. And because it's resistant, that also causes problems with the moisture being condensed and all these kinds of things. So, any questions? Other questions?
Yeah, does the blue actually have to be on top because we put that a lot, or it needs to be?
So
on
it
top
used to
that
be.
way,
It used to be.
water?
No. Well, therapeutically, it doesn't make any
I
difference.
mean, for the rain out.
But for the rain out, if you wanted to come out through the expiratory limb by just simply the physics, heavy air coming in this way, you'd want on top so that as it's wicking out, you want it to drain below. Whenever I do training on my CPAP devices, I always put the expiratory limb below, and that seems to help with Rainout to a degree.
But most of the Rainout I see is only in the inspiratory limb,
Right here,
or just wherever it's falling down, you know,
Right.
wherever it loops down.
if you have this extension unit, which they were telling me you
Yeah,
guys
we have
always
that.
have it,
Yeah,
then you're going to get so much Rainout just
Yeah.
in this guy alone. Because let's go back to what we were looking at. I want to visualize this. So based on everything we've discussed, let's say we put the temperature probe outside the heater, which is common. Let's say we have a baby in prone. Let's say we've connected this like so, and it's cooling, and now Rainout just starts to build right there before it even gets to the baby. Because then we've got this could potentially be, I mean, it's just a wave of circuit activity, and you really want it to be going straight down.
Right,
it's-
makes sense.
yeah.
So this applies only with the CPAP?
No, with high
ET
flow,
tube?
whenever I do high flow training as
How
well.
about with an ET tube?
Okay, so ET tube is challenging because you're trying to make sure you don't do an accidental extubation, so you've got all these. But if you keep the circuits going down below all the interfaces, that is encouraged just to keep the Rainout away from it. But then the ET tube, depending on the type of setup you have, sometimes they come up and then go straight down like that. You do the best you can in that situation.
High frequency and all that, you want to keep it straight, but you want to keep it steady.
Right. So ET tube is different. It's just got a different parameter because of those accidental extubations that people are concerned with. I don't sell ET tubes. I don't work with ET tubes. So
No, it's not about the ET tube. There's a question about the condensation.
if you can keep the circuit below the ET tube and not have a partial extubation, then do it, because that'll keep the water going out.
So what about changing the temperature? Because sometimes, like, you know, with invasive and non-invasive.
Let's
you
talk
keep
about that. I'm
changing
glad you
the
brought that up.
temperature
Okay.
To decrease the condensation.
So to recap, why do we have it at 37 degrees? Well, why does our heater say invasive and non-invasive? Why would we give you that option? And then why do we say 37 only for NICU? So to back up the first reason, it's most people who are on the heater are adults, and they have an ability to kind of push back if it's too hot. So if you're doing a BiPAP mask or something like that, they'll say, okay, that's too hot. Can you turn down the temperature for me? Do that. But ultimately, even Fisher-Paykel's goal is to get even the adults up to 37 degrees because we feel our system works best at that temperature for adult patients as well. But they can push back and then you lower the temperature. In a child setting, if you have it at anything below 37 degrees, to the video that we talked about online, like you drop down to 34, you're no longer at optimal humidity. What does that mean? Well, in the video that we shared with Lisa and some of your colleagues, is the mucociliary function starts to stop after about 15 minutes of just a decrease in temperature. And so the pathogens aren't moving as much, all the debris is not moving as much. And then after an hour, the whole area dried up and nothing was moving, just by that simple change in humidity. That's problem number one. Problem number two is our natural state, what we do as adults, is when we breathe in, and it's not the right heat and temperature, we give that airflow, heat from our body and moisture from our body to bring it up to the level we want. Babies don't have that spare heat and moisture to be able to do that. So for a NICU nurse who's trying to keep their heat inside the body and the moisture inside the body, all you're doing is just extracting that that they're going to do naturally. And then finally, when we breathe in, we're breathing in with this, it's just a flow being pushed in for them at a relatively fast clip. So it can dry things out, it can do all the stuff you need to make. And the air coming out of the wall is very dry that we have to get humidified. So that's the why.
But it doesn't change the condensation.
It will lower the condensation if you lower the temperature, but it will have different negative impacts on the baby directly if you lower the temperature. They're just not going to function as properly with a lower temperature. But yes, we'll lower the condensation. Yeah, we will.
think we should do that.
No, it's about the baby,
Yeah.
not our convenience. Right. But yeah, they burn a lot more calories
Burn
as
more
well
calories.
to try and get their bodies, to get our air up to 37.
So if you
Burn
can,
those calories.
right. Our position is if you can get optimal humidity and control rainout simultaneously, then that's the goal. And so by doing, if you position the circuits, it will reduce rainout. We'll share that video so everybody can have like tips on, okay, where do I put the circuit? Any other questions?
No, the other thing that I've been doing myself, I mean, we do have it like this most of the time. I keep it down here or out here, like you said. And I've been tweaking this
That's good, because you always want the expiratory limb below.
like this so that it's not up like this. I make sure that this is tweaked
Right.
as far as I can without it kinking.
Okay, so if you could do this, that would be better.
Yeah.
So
okay.
that the circuit is running into the expiratory limb. If you
Okay.
do this, then you're creating a potential
Oh, okay.
U-bend right
Right.
there. So just, you take a look at it, you go, where are my U-bends on this and how can I eliminate those? So that the water, because the water right here, you can see right here, water's just gonna pool right there.
So try and get
And
it
when you-
straightened downhill.
Right, if you move the baby around, are you shifting water into the baby's face? The other thing is when you have water building up in the expiratory limb, what goes up? CPAP. The
Right.
CPAP is
Yeah.
going up because there's nowhere for the air to leave, and that increases the pressure.
Okay.
Sweet, thank you.